Hi, this is Math 1340, and this video is over section 2.2. We will be breaking this into two parts. Try to get this open. There we go. And we're going to look in this first part at increasing, decreasing, and constant functions, maximum and minimums, which we won't have actual algebra methods to solve this just yet, but we'll look at determining them from the graph. And then we'll look at a couple applications, and then the piecewise function, and the greatest integer function. That'll be the last section. The second part to this video, we'll look at symmetry. Alright, so increasing and decreasing. Let's start with just linear functions. If you have a function that is going up and to the left, we have that as an increasing function. So increasing meaning that as it goes from right to left, it also increases in value. Okay, think of this as over time. If this is like your time and your bank account, you want to see that increasing. So you want to see the numbers get bigger and bigger. Right, so with that, if we have a linear function, so let's say f of x equals 2x plus 5, we see it's increasing. The 2x, 2 there is what causes it to increase. When that number is greater than 0, it's increasing. If we make that 2 negative, it's decreasing. And that is as you go to the right, you go down. Okay? And there n will be less than 0. And then the last thing is if it's constant, then it's a straight line. You don't have x term, so m is equal to 0. So there's no slope. It stays the same, so the function equals the same number every time. Right, so let's look at f of x equals negative x squared plus 5. I know I have the picture here, but graphing it in Desmos, you can actually see that that is 0, 5. Right, now you're increasing as you go left to right on the left side of this. So the way we write this is we always look at the x values. From negative infinity, that's the farthest left you can go, to 0, this is increasing. And then once it reaches that max value, increase on this side, it starts to decrease. From 0 to negative to infinity, decreases. Always use the x values. We only ever use the parentheses with these. So you don't have to worry about brackets. It's not like the domain. And then we can see that there is a maximum spot, and it happens when you switch from increasing to decreasing. And at that maximum spot, your x value equals 0, your function is 5. And we call this a relative maximum. It doesn't always mean that it's going to be the max for the function. You can have another part of this a graph, and we can see that in certain cubic functions that may be higher, but in this relative area, that is your maximum. You see it when it switches from increasing to decreasing. If we look at x squared minus 3, we have upside regular parabola this time. We see that bottom part is 0, negative 3. And so it's decreasing first, It's decreasing from negative infinity to 0. Then it's increasing from 0 to infinity. And so we have a relative minimum at x equals 0, which is -3. So if you plug in 0 for x, you get -3 out. So really, right now, the only way you're going to locate the minimum for anything that's not a quadratic, so anything higher like cubic and fourth power and fifth power, would be to graph. Right, so let's look at f of x equals absolute value of x plus 4 minus 3. So do absolute value, click on that, x plus 4, and then minus 3 is outside of the absolute value sign. And so absolute value always has that V shape to it. So that's a -4, -3. So the relative minimum is your -4, -3. You're decreasing first as you go from left to right. You're decreasing from negative infinity to 0 to -4. Choose your x values. Increasing after that from -3 to infinity. Now, absolute value, you break that function into two different functions. The first function is going to be your x plus 4 minus 3. And we see that we have a positive slope. Your other function is going to be a negative x plus 4 minus 3, which is going to be negative x minus 4 minus 3, which is negative x 7. We see here that's the negative slope. But that's why one side is decreasing and one side is increasing. So relative minimum is at -3, and it's at x equals -4. Now let's look at cubic. X cubed minus 16x. Zoom out some. Change this directly to -5, 5. Okay, which I don't have. So let's do 20. 1. Doesn't seem like it's everything in, so let's do 30. 30. Trying to make sure I have everything in. There we go. All right, so we have a relative max at -2.309. Relative min at 2.309. Now these aren't going to be exact, but for this class, we are going to have values that are going to be able to find these, or methods to find these as exact. That would be in calculus, right? But so we'll have to round these. So this point again is -2.31 and 24.63. Point down here is 2.31. With cubic, a lot of times you see that they're just opposite signs. So it's increasing on the far left from negative infinity or negative 2.31, and it's increasing in the middle, decreasing in the middle from negative 2.31, 2.31, and then it's increasing again from 2.31 to infinity. So with cubic, you'll see that it'll switch a few times from increasing to decreasing, or from decreasing to increasing, and then back again. Relative max is in 24.63 at negative 2.31. Relative min is negative 24.63 at 2.31. All right, so a couple of applications. An airplane is flying at an altitude of 4,300 feet. The slanted distance to the airport is d feet. So this is a plane. Not the best plane. that did not go well at all. Me. There we go. And it's flying, and you've got slanted distance to the airport. So stop for that. Or that's D. The height, or at 4,300 feet. And then we're going to call H the horizontal distance as a function of D. All right, so this is going to get into the Pythagorean theorem. H squared plus 4,300 squared equals D squared. And we want to express this as a function of D. That means we got to solve this for H. So H squared equals D squared minus 4,300 squared. And then we can take the square root. So H equals square root D squared 1,300 squared. And to express this as a function, H of D equals square root minus 4,300 squared. This is mainly an application of how you would find a function notation from a given word problem. Now we're going to do one that goes over finding the maximum of an equation. So we have 60 yards of fencing, and we're going to enclose a rectangle garden. The garden X yard wide. Express the garden's area as a function of the width. And so it's going to be rectangle, and the width is going to be X. The length is going to be L. Okay. We want to express the garden's area as a function of the width. So A of W is going to be equal, well, A of X, width is X. It's going to be equal to X times L. But L is not something that's given at all. So what we're going to do is we're going to use the perimeter, 2x plus 2l, and set that equal to 80. And then solve this for L. So actually divide everything by 2, you get x plus L equals 40. So L equals 40 minus x. And so we see that L is a function of x in itself. So we have to plug that in. I have the area as only a function of x. Okay, so A of x equals 40 x minus x squared. Okay. Now, domain of this. For polynomial and quadratic, the domain is normally going to be all real numbers. However, with word problems and applications, domain also has to take into account what can physically happen. Right? So all length or all width cannot be less than 0. And in a sense, width can even be 0. That matters. So width has to be greater than 0. With that being said, a length can't equal 0 as well. And if we plug in 40 for x, we're going to get a length of 0. X also has to be less than 40. So our domain, the x has to be greater than 0, less than 40. Alright, so now let's graph this and find the maximum area. So 40x minus x squared. And we're going to be pretty high there. The maximum out is when maximum x equals 20. So with a 20, area equals 400. And if x is 20, L will also be 20. So you're looking at a square here. All right, piecewise function. We actually already seen one, and that was the absolute value function. It's a piecewise function. For this, I'm going to do this Desmos. So we'll have 1/4 x as one piece of this, and we'll have, I'm going to call this f of x, otherwise it won't graph it. It's the same as x equals 2. Right, now, with piecewise functions, there are certain restrictions already in the domain. So the 1/4 x is only going to be when x is less than 0. So we have to make that in Desmos. So x less than 0. And so we see the blue line is now only on the left side. And then for the x plus 2, x can only be greater than 0 or equal to. So we see the green line then is on this side. Okay, now, at 0, I want you to notice that they are not at the same point. Right? At 0, the 0,2 on the green is included, not the 0,0. It will show up as 0,0 if you click on it, but that's not included. Okay, so, and that's because 0 is not included in the 1/4 x. So for this, you'll open circle there at the 0,0 and close circle 2,0. And then we can graph it. For x plus 2, we're going up 1 each time. Like that. 1/4 x, we're going rise over run, so we're going up 1 over 4. Like but they all, this is a function, so there shouldn't be any way they cross if you do a vertical line. And any time where they could line up, one of them has to be included, one doesn't have to be included. We can see this in a table. If you make this x, f of x, and in the column f, capital F of x, Pick a negative value, -4, let's say. You get f of x, you get an answer. You don't get an answer for f of x. Capital F of x. If we do 0, notice again, you only get it for the capital F of x. If we do 2, again, only for the capital F of x. So if we want to find f of -8, it's only going to be for the 1/4 x. So f of -8, you're used to 1/4 -8, which is going to give us -2. One point on this, that's off the graph. F of 5, you use the x plus 2, which is going to give you 7. I'll plug in 5, I'll get 7. Okay. We can do multiple. So we'll have g of x, -3 minus x. This is going to be for x less than 2. 1. Oops. I'll call this capital G of x. That's going to be when x is greater than or equal to 2 and less than 4. And then we're going to have one more, so I'll have to plug in a third one. We'll call this h of x. X plus 2. That's going to be when x is greater than or equal to 4. I'll get this table matching up. One more. Okay. That's fine what this graph looks like. So we see -3 minus x is a downwards decreasing graph. 1 is constant, and then x plus 2 is increasing. At 4, you see that that's where it stops. So even though, let's see, 4 you'll get 6. 4, 6 here is included. And that's increasing. The 4, 1 is not included, even though you can click on it. It will not be included. So again, we can see that here. If we type in 4, it's undefined for the first one. It's undefined for the second one. It's only defined for the third one. And then same thing with 2. Undefined for the first one. It's 1 for the second one, so it's included there. And for the third one, it's also undefined. And then let's see, this is going to be 2. About 2 -5. And that's going to be open circle because that won't be included. Then it crosses the x-axis at 0, -3. Sorry to use that to graph. That's what the graph looks like. Everyone know g of -1. We'll use -1 is less than 2, so we'll use -3 minus x. x is going to be -1, which is going to be equal to -3 plus 1, which is going to be equal to -2. 1 gives you -2. And then g of 6, do the third one. 6 plus 2 gives you 8. And you get 8. The third one. Piecewise functions, they're just separate graphs, almost like separate functions put together as one whole function. Gray's integer function is unique, and it's also called a step function. Basically, Gray's integer of, let's say, 1.7 is going to be equal to 1. It's the whole number that was the highest right before that decimal. And so, Gray's integer of 1.2 also equal 1. Gray's integer of 2 is where it goes up to 2. Okay. So the way the graph looks is like a step. We have at 1, anywhere between 1 and 2, when x is between 1 and 2, you have it equal to 1. And at 2, it jumps up 2, and it's at 2 until you get to 3. We'll do open circles on this side. So it really looks like this step pattern to it. Keeps going on this side. So Gray's integer of 0.3 is equal to 0, stays at 0 there. Gray's integer of -2.5. -2.5 is about here. You're down to -3. Negative's a little bit different. You go lower. You always go lower, but you go lower, but your number gets higher. 2.5. We don't do a whole lot with this, but we will do derivatives of it in calculus, so that's why it's being mentioned. Okay. Next video, I'll start symmetry. I'll see you then. Bye.